And so he gives us another example, which he says is probably the most important scientific, philosophical, and religious debate in history, right? And that's the 17th century debate over the geocentricity and the heliocentricity with regard to our solar system.
This
right?
was big news back then.
That's right. It was a big debate. It was a big argument, right? On one side were the Copernicans, right, that says, hey, look, the sun is the center of the solar system, right? Heliocentricity. On the other side were the Ptolemies or the Aristotelians that says, no, the Earth is the center of our solar system, right? Geocentricity, right? And so he says, now it's important here that the debate was not about, notice, observation.
Yeah, very important here.
Yeah, right? Everyone generally agreed that the sun is over there at some point, at some time, and then the sun is over there at some other time, right? Everybody agreed with the observations.
Everyone sees it, sure.
Yeah, right? So the debate was over how to explain the appearances of what was going on that everybody observed. Right? And so the debate, he says, was about theory. That's the explanation of our observations, the explanation of the phenomena that's being observed, right? He says, obviously, we don't observe heliocentricity or geocentricity, right?
Unless you got further outside and are able to establish where the center of anything was in the universe.
So those theories, he says, are inferred stories about what goes on behind the appearances that we have. So so in the Copernican debate, each side had a possible answer to the question. Here's the question. What does the sun, or why does the sun move the way it does in the sky? Why does it move the way it does in the sky? Well, one side says because the Earth, so geocentricity, the Earth is spinning and rotating around the sun, right? It's spinning on its axis and rotating around the sun, spinning approximately every 24 hours and rotating roughly every 365 days. And that then is the explanation for why we see the sun here at one point and over here at another point. The other side says, no, the sun is moving around the Earth, right? And that's the explanation, right?
Right, and it's not just apparent. Like, a good history of philosophy or philosophy of science class will kind of bring you into the fold of exactly how long this took. Like this Copernican revolution was over a long period of time,
several hundred years,
and really the thing that kind of caused issue was planets kind of doubling back on itself, and there's no explanation for that within a certain theory or a certain model.
Well, and oftentimes, and he doesn't get into this, but oftentimes technology allows us to help in some of these debates, right? So the telescope, the newly invented telescope, then allowed, for instance, the observation that, lo and behold, Jupiter had satellites going around it. So not everything then is circling around the Earth. And so that was the evidence, used as evidence, right, to show that something else was going on. But anyway, he says an explanation then is often an answer to why questions, right? Why do things appear this way? So a theory then is an explanation. It's an explanation about why. The type of inference leading to each theory, we can call this inference to the best explanation, he says, is as complicated as it is common. And so he wants us to understand this particular complicated process of how we come up with theories, how we test theories, and all the real hard work that it takes up, what science is all about. So he says science then is in the business of inferring theories, and scientific theories must agree with observations, right? Past, present, and future. These theories must make contact with the world, but no matter how well a theory predicts or represents observable phenomena, no matter how well it's supported by this agreement with observation, it's still a theory simply because it's not observed, it is inferred, right? We infer it. We look at the guy standing in the office soaking wet and we say, it must be raining outside. Now, as you mentioned, there are other theories, right, about what might have caused them, right? He walked through, the sprinkler suddenly came on while he was walking
There's a
by.
prankster who's
Yeah.
got the old bucket over the
Yeah,
doorway
the
filled with
doorway,
water.
yeah, all kinds of things, right? So those are various theories. We might even say in what he's going to talk to us about, hypotheses, right? Are theories, but they're inferred. We didn't observe the bucket, right? And we didn't observe the sprinkler, and we didn't observe the rain. We're making an inference
Right.
based on what we do observe.
Even if you have that person say, I was rained on, you have to still infer it because you're inferring, is this person trustworthy? Is this person mistaken?
Yeah.
Is this person of sound mind?
Yeah, good. So there's basically three ways then that we do this in terms of coming up with beliefs. There's observations that kind of force our beliefs, right? Right? I mean, it is raining, right? Yeah, theoretically.
Yeah.
There's inference, right? Oh, it must be raining because, he's soaking wet in my office. And then there's testimony. That's what you just said, right? He told me that it's raining outside. So those are at least three ways that, we kind of
Hume would not like our testimony.
Yeah, he wouldn't like that one, right. All right,
testimony is also how we sneak in God into our worldview there, too.
So the real question, he says, is this: how good are our reasons for believing theories, right? How good are our inferences, right? That's what he wants to examine, right? So theory then is this as an explanation. It's an attempt to answer these why questions. Right. And so now he wants us to examine how good are these reasons for believing a particular theory? How good are the inferences that we make with regard to these questions, right?